Okay, good morning. Welcome to
Number 590.
FamilyMath590. Originally, we were going to do 3 videos on Grant Sanderson's new regularity and primes video, but it was so cool that we just watched the rest of it twice, actually. Actually, once yesterday and once today, and now we'll just talk about it for today. So what are some things you remember from the second part of this video that you thought were interesting?
The chi function.
Okay, the chi function. Chi of n. And how did that function, how was it defined?
Well, if you put in a number, chi of n, if n is 1 more than a multiple of 4, it spits out 1.
Alright.
If chi is 3 more, if n is 3 more than a multiple of 4, it spits out -1.
If it's even, it's 0.
Alright, so does that hit all of the choices?
Yes.
It does.
Okay, why?
Because the numbers, so even numbers are either multiples of 4, 2 more than multiples of 4.
Uh-huh.
And these just give the 1 more than multiple of 4 and the 3 more than multiple of 4.
So chi of n was an interesting function. Do you remember any special properties about that function?
Well, it's like you can do multiplication and like operations with it.
Yeah, so he said it was multiplicative. So we'll study that in a little bit. So yeah, chi of n played a really important role, and it's a really neat and very simple function.
Yeah.
In fact, so simple that it's hard to believe that this function could be of use to anyone, right? Mm-hmm. But it turned out
It's
It was.
very useful.
very useful function. Okay, what else? What else was in this?
And then the infinite sum for pi.
All right, what was that?
Like the infinite sum itself.
Yeah.
I think it was like 1 minus a third plus a fifth minus a seventh plus 1/9. It was like all these 1 over an odd number, and it just went plus minus like that.
Uh-huh.
And this sum is pi over 4.
Pi over 4. All right. So what was going on here?
So he used chi to find like all the divisors of all. He used chi to find all the divisors of all the numbers that he was taking the square root of. That was below square root of r.
Uh-huh.
And then he looked at the numbers that had a 2 in them. And he looked at numbers that had a 1 in them. That was all of them.
Yeah.
And he looked at the numbers that had 2. That was roughly a half.
Uh-huh.
And then the numbers that had 3, it was a third, and so on.
Okay. And so this came out, so this chi function,
Basically eliminated all the even numbers.
yeah, and it was, but we don't have to get into the super details right now. We'll get into that in a second.
And then he ran this through the chi function.
Uh-huh.
And then, so he used this and got rid of all the even numbers and just
And this-
alternates with chi.
This amazing formula came out.
Yeah.
All right. What else? So from the last 20 minutes of the video, this was the new function. This was the main result. What else was he talking about in these last 20 minutes?
So he
Looks
was
like a
talking
little-
about how to he was talking about how to like split these like he was talking about how to make different complex conjugates.
Sort of like how to factor numbers when you're allowed to use complex numbers.
Like I.
So factor numbers in the Gaussian integers.
Yeah.
All right. All right. So yeah, these are the 3 big things. So let's go through these examples, and we'll talk about these things, and that'll be a good summary.
All right.
Okay.